Good evening, everyone, and welcome to our final episode of the semester of After Hours in the STEM Center with Rance Bobo. It has been a pleasure to be able to do this semester, and it looks like we will be in the same modality in the fall. Well, this evening we have a very special guest. Every semester we try to bring on one of our faculty members, one of our instructors. And so this evening we've been privileged to have Dr. Liu, who is a new biology instructor here at Kenyatta College. So, Dr. Liu, I'd like to welcome you to the stage.
Hello, everyone. I'm Dr. Julie Liu, and I'm a new associate biology professor here teaching biology.
Well, Dr. Liu, thank you for spending the time with us this evening. We do understand that you do instruct class all day, and the evenings are yours, and hey, who doesn't want to sit down and unwind, especially being an instructor. So it's great to have you. Also, to you viewers, we are taking questions live, so please feel free to ask questions about anything that we're talking about, and then we will take them as they come in. So, Dr. Liu, after reading your bio, boy, you have a very interesting journey, and so you are a Bay Area native. So, can you give us a little bit of background on your upbringing, and then where you went to school, why you chose that major, and then we'd like to know too, why did you decide to be an instructor? Because I mean, after reading your bio, you could be doing other things that are very interesting.
Yeah, well, first of all, thank you so much for inviting me to come here and participate. It's wonderful to be a part of the speaker series here. And with regards to my journey, I am a Bay Area native. I was born in San Jose and then moved to Palo Alto. And so I definitely come from around this area. And in fact, I went to the local community colleges nearby. So I went to Foothill College and De Anza College first as a K through 12 student in the programs that they had there in the summer. And so I got to experience community colleges, not just with regards to the academic classes, but also with regards to everything else that it has to offer. So I remember being able to learn a little bit about astronomy as an elementary school student, and then trekking over to the swimming pools that they had nearby, playing badminton and checking out archery. And it really let me know and experience that community colleges offers important things beyond just classes, but that it also gives an opportunity to meet such diverse students that are also on campus. I met so many different students there, but also be able to experience it as a place to explore. There were so many nooks and crannies. For example, in the library, I was able to find these old timey newspapers that were there. I also realized that the classic film classes had videos there that I was able to watch, um, but also be able to just hang out on the lawn outside. And so it was nice to be able to experience all that it had to offer.
Yeah.
Um,
Oh, sorry. Go ahead.
mhm.
No, I'm just saying, that's pretty awesome because, sometimes, um, people hear the term, community college or just college, they kind of box themselves in on what it has to offer. It can just be straight academic, but at the same time, it can be enrichment, where you can get that enrichment. So that's pretty awesome. But please continue. I'm sorry to interrupt.
Yeah, it was wonderful, especially later on as I grew older and I was able to take undergraduate courses there. One of the things that I love to do is to trek across to the cafeteria on the other side of the campus. And then I found just some other people who usually ate lunch around the same time. And so it was just a way to kind of meet other new people there too and kind of build this interesting routine that was just beyond classes itself. And so it almost became like relaxing if I give myself that moment to just kind of enjoy the fact that I had to walk completely across campus and enjoy walking in the sun. And it became a nice time to just kind of relax for those moments.
Right, right. And created that, you know, as you say, you can find those moments of peace and quiet, peace of mind, so to speak.
Yeah, exactly. It made me realize that if I could learn to kind of focus on um, enjoying myself in the ways that I can and whatever activity that I'm doing in that moment, it could kind of help maximize, uh, you know, that activity more and make me enjoy it more. Um, but then after that, I applied for some colleges and I decided to go to University of California, Davis. Go Aggies. So UC Davis. And so I moved up to Northern California and did my undergraduate degree there. And actually, I was undecided for a majority of my time there, which is something that I wanted to emphasize is um, trying to find a direction, because sometimes when you're trying to decide what am I going to do, my philosophy was trying to pick out what I was interested in, and at that point in time I wasn't sure. And so my philosophy was to use my time in the school to take classes and explore the things that I was interested in. And so usually there are some kind of pathways, or when you talk to counselors, you can kind of figure out what are you generally interested in. But you also need to take general ed classes too. And so during my time there, I really tried to take advantage of the fact that I needed to take a range of classes. And so I ended up taking psychology, sociology. I also took science because I was interested in science classes too, but I also took linguistics, and I loved that I was able to take such a range of classes. And I also took volleyball because I always wanted to learn how to take volleyball, uh, but I wasn't skilled enough to make it onto the volleyball team in high school. But at college, you could take these classes and learn how to do it for fun. And so I took those classes and I realized what subjects I was particularly interested in. I really loved psychology and being able to learn more about how we behave. And in linguistics, I was fascinated by the fact that so many languages had these patterns that you could try to parse out and adhere to, and that you could even try to code various programs to try to follow certain patterns of language. And in the science classes, I was really interested in how these mechanisms could help produce behavior that I was learning in psychology, and how it could help uh, organisms or humans adapt to be able to produce language. And so, what I did was that I tried to take these things I was interested in and just figure out what is my general direction? What route do I want to go? And I knew that I wanted to go in a route that was able to incorporate those interests. And so in science, it kind of helps incorporate that. And I thought something maybe neurobiology related could integrate that, because the brain helps you process what you're hearing, and it's able to determine how you respond to it and ultimately produce the types of behaviors that you use to respond to something. And so, with that, I kind of knew what general direction that I wanted to go. And I just kept on trying to determine what classes and what activities I could do that would help propel me in that general direction. And along those lines were seminars. So, kind of like here, we have a webinar. So, hello, everyone. Thank you for coming. I also went to seminars. And I remember I would look at seminars and see what was interesting. I almost took one on how to fly paper airplanes. But my first semester, I ended up taking one on spinal cord injury recovery. And it was a professor at UC Davis who was researching spinal cord injury and how you can help develop treatments to help reduce the severity of spinal cord injury. And I remember her passion for spinal cord injury was absolutely hypnotizing. She would come in and she would be so excited to share what research was being done. But she also brought in people who are doing spinal cord injury research, but also patients who are coming in and sharing their perspective and how much they appreciated what was being done in the spinal cord injury research field. And so for me, as a student, I was like, wow, this is amazing. I just loved the passion that she had for it. And I remember thinking, I would love to have that same kind of passion. And I would love to be able to work with a person like that who could help share how to, you know, to share that passion and to help me also be able to perform that kind of research too. And so there's always this thing where you think, how do I do that? Or what can I do? And this leads me to the next tip or advice that I have.
Okay, first, before we get to that next one,
Yeah, yeah.
I just want to unpack a little bit of the first bit. The first piece of advice that, which is great. I'm glad that you mentioned it. Was that, you took your time to explore,
Mm-hmm.
find something that you truly enjoyed. Um, because sometimes, students, they get advice, um, do this because you'll make a lot of money, or, you know, do this so you can be successful, or for the prestige. Uh, sometimes, and I always tell students, look, you know, you want to do something, study something that you're going to want to do every day for the rest of your life, or how you can have a positive impact on society, because sometimes, people do things that they really don't want to do,
Mm-hmm.
and so I'm glad that you touched upon that. And also too, I was thinking, you said something that about the psychology and human behavior, and then I like how you tied in, how you mentioned the linguistic part, and it's so very true because everything, if you think about it, everything that we do as people, it's kind of like a rhythmic counting system. It's the way that you take music, you take dance. There's some type of steps to it. Even with you talked about programming. Well, it's just like with programming with video games. Of course, the early start of video games, it was like a counting system, and this is like, oh, I know how to beat this because you know how to count. That repetitive motion, and like you said, it does affect our behavior. So that's pretty cool how you picked up on that, and then you started to pursue that and study that. That's pretty awesome. And so we, that's glad, it's good that students should, take their time and figure out what they want to do. And
Mm-hmm.
with that, figure out how you can make that work for you later on. Because, they say if you, the person who truly enjoys what they do really never works a single day in their life. You
Mm-hmm.
know what I mean? So that's awesome that you explore that. Now, spinal cord injury stuff is cool. I have some questions on that, but we'll get into that later. So, okay, let's go ahead and move with the second piece of advice.
Yeah. So the second piece of advice is that is although sometimes you might not necessarily be sure or you might be uncertain, my advice is if you can, reach out and ask. And so, as a student who was taking the seminar, I found her passion so exciting, and I wanted to be, if possible, a part of it. And so, um, and so I sent her an email telling her that I was really interested in what she was doing, and was there a possibility that I could potentially work with her and learn from her. And um, and so in this case, I was really fortunate that she said yes. And I think this is something that I have actually experienced a number of times since then. The lesson that I learned was that if you can ask someone, um, you can open up opportunity. And there's sometimes an uncertainty about what's going to happen. But my suggestion is to perhaps look at it this way. If you ask, the person you're asking could say, I apologize, I don't have the time at this moment. Or the other thing that could happen is that they say yes, or they give you an opportunity with someone else. And if you don't ask, you know for sure that the answer is going to be no. And so, if you can maybe take a look at it that way, that's what I use in order to help give me the motivation to say, I'm going to ask and see if there's a chance.
Right. And last week, the speaker had said the same thing. Like, you know what? You have to ask. And it's about self advocacy, you know. And I like how you put that. If you don't ask, it's automatically a no. It's a no. It's a given. It's a, but, you know, if you do ask, you don't know the answer that you can get. And the truth is, sometimes the person might be willing to help, but they might not have the resources. But there's a possibility that they know someone else that can provide you the resources that you need. Or you might be a better
Mm-hmm.
fit with someone else, even though they might not be able to provide it. And that is so true. People have to be willing to ask and accept rejection because, you're not going to get a yes for everything, you know, especially
Right.
when it involves your future. I'm just like, look, this is your future. This is, for your growth, you know. Whoever you're afraid to ask, they already have, you know, whatever they want. So it's just like now you have to try to get out there and obtain what you want. So
Mm-hmm.
yeah, that's so awesome. That's awesome. Now you go okay. So you finish your undergrad, and then what do you continue to do? What after your undergrad?
Yeah, so in this case, actually, a little before I finished undergrad, what I did is that I had worked with Dr. Candace Floyd, who was the one who did spinal cord injury research. But halfway through, she actually moved to another university. And so, with that, it gave me the opportunity to try to think, what am I interested in doing next? And so With regards to this, given that I was interested in these various classes, psychology, linguistics, I also had taken philosophy. I was like, I want to try the brain if possible. And I wanted to learn more about that. And so what I did was a similar thing again, where I had learned if I ask, it can potentially give me opportunities. And so I emailed a variety of professors at UC Davis who are interested, who are doing research on the brain. And I was really lucky that actually two of them were willing to help mentor an undergraduate student. So not only did I have one opportunity, I had two, and I was able to have the choice of, who I'd like to work with, which was amazing. But I then started to work with Dr. Leah Krubitzer, studying how the brain develops. And in her lab, what I did was study how congenitally blind um, people how the connections of their neurons develop. And so, in particular, in the brain, you have different parts of the brain devoted to processing different types of information. So, you have the visual cortex to process vision, the auditory cortex, and usually it's thought to process only those information. But the question was in people who are partially blind since birth, is that true? Does the visual cortex only process vision? And we know just behaviorally that it seemed like people who are blind have enhanced senses of what they have remaining, hearing and touch. And what our study found was that the visual cortex no longer processed only vision. It actually processed auditory information, what you heard, your sense of touch. And so it's as if the part of the brain that processes vision in people who have vision is now processing other types of senses in those who are blind from birth, which might account for why they have enhanced senses of hearing and touch. And so, with that study, um, it really helped me decide that I was really interested in pursuing research of the brain. And in particular, I wanted to learn how that develops. Because we figured out that the visual cortex in congenitally blind patients who are adults, the visual cortex processes other types of senses. But for me, I was interested in how does that develop? Why does that occur? And so, um, what I did is that with that type of experience, I decided that I wanted to pursue a PhD in neuroscience to learn how these neuronal connections were forming in the brain.
Okay, so wait, now I gotta ask a question because man, you really piqued my interest. So you're saying someone who was born blind were also born with enhanced senses in other areas?
Uh, Actually, we found that they develop that.
Okay, they developed that. Okay, okay.
Yeah.
So now this is just an offshoot question you might not know. So if someone who had became blind later in life, would the same process happen as well? Would they develop, hypersensitivity in their hearing, touch, and smell and things like that as well?
Great question. So, there is this term called plasticity, where you have a certain window with regards to age and how plastic your neurons are in forming connections. And so, um, the older that you are, the less that it can actually modify those connections. And so, just to take a step back, with regards to development, since I was really interested in development, uh, what I did is that I actually proposed a project. And this is one of those things again where I decided I'm going to just try. And I found that there is these centers at UC Davis analogous to the STEM Center here at Kenyatta College, where they would list various types of scholarships or things that you can apply for. And I saw that there was one for research fellowships for undergrads. So I decided, you know what? If I don't try, it won't happen. But if I try, it might happen. And so I decided to apply for whether I can look at the development of those connections. And I was able to receive the fellowship to research that. And so, what we found is that actually, what happens during development is that your neurons, it's a normal process for it to form a lot of connections. And then, what I'll do is a process of pruning, where it actually prunes back the ones that it's not using as much. And so, in the case of someone who has vision, because they're going to be using the connections to the visual cortex, they'll prune away the neurons that processes hearing or touch because they don't need those in the visual cortex. But for the congenitally blind patients who are blind from birth, what happens is that those neurons from all of these senses, they're forming a lot of connections. And at the point where it normally prunes, it realizes, hey, the visual cortex, the part of the brain that processes vision, it's not firing as much because it's not processing visual activity. And so it says, we're going to keep our connections there so we can use that part of the brain to help process our information.
Oh, no, that's awesome. So typically it's just like, okay, we don't need this. Let's just cut back. But
Exactly.
so in this particular sense, like, wait a minute. We're not getting a signal here. Let's keep our fingers on the pulse because something's not coming back from this side. That's awesome.
Exactly. And so, to get back to your question, if someone becomes blind later, if they're past that window of plasticity, they might not be able to regrow the connections there.
Oh man, that is pretty. Wow, that's pretty interesting. That is something. That's amazing. That's
Yeah.
amazing. Thank you for, excuse me, explaining that. Thank you for explaining that. That's awesome. That's good to know. Um,
But that actually leads me to one of the points that I did want to emphasize, which was to take advantage of looking at those centers that do list those opportunities. And so for the STEM Center, they list scholarships that you can apply for, internships that you can apply for, and opportunities there. And I suggest if you look through it, and if there's something that interests you, um, I suggest try for it because you have a good chance of getting it if you apply for it. And it's the same thing that I mentioned before with regards to asking. If you don't apply for it, the answer will be no. But if you apply for it, the great thing is that it could be yes.
yeah, and also the truth to what you're saying is, um, apply for it because the truth is a lot of people don't apply for it. You know, a lot of people don't apply because they think they might not be qualified or something. So yeah, apply for it. Uh-oh, we got a question. And this is an interesting question. This is a really good question. So the question reads is how does this brain development and plasticity relate to today's children missing learning in school from COVID? Plasticity. That's the word.
That's a really good question. With regards to this, there's this idea or this term that's being used in the field, which is called enrichment. And one of the things to keep in mind is that you can get enrichment in multiple ways. And so, even if we're still online and we're taking classes online or we're learning at home, you can still take steps to have that enrichment at home or provide that enrichment with the children. And so That's kind of how I would address that, in the sense that um, it's a different modality, in person versus online. But either way, whether you're in person or online, you can provide enrichment in both settings. It's just, what do you do in order to provide that? And in both settings, one of them is to interact with the children. And so if you check in with them or ask them about their studies and what they learned, that is a really big step in providing that enrichment still. Great
Mm,
question. Hmm.
yeah, that really was a great question. So,
Yeah, but it's a big thing now in neuroscience, is that term enrichment, and what does it take to reach enrichment. And the thing that's really interesting is that you can achieve enrichment in a number of ways if you just take the steps to try to provide it.
right, and also too, I think when you use that term enrichment, they find that with hands-on tactile learning, you know, that really strengthens enrichment in a lot of communities. They find that a lot of people tend to be more tactile learners than audio or visual. They find that students sitting in a class listening to someone talk about it, it may not be the best, and it was really big in the 70s and 80s. That's why I had like the polytech schools, like Cal Poly Pomona, along those lines, where it's just like, their motto is we learn by doing. So it really helped with that enrichment. Um, so back to that plasticity and the brain, you said when you're younger, you have that. But when you're older, it kind of just, if you're older, you lose your vision. It just, they don't reach back out anymore, huh?
It actually depends. So it depends on the neurons or what the cause was. So there are some studies that show that you can potentially um, form, there's different types of connections that your neurons form. So you'll hear about how, if you take biology, come to my human biology class, even anatomy or human physiology, we'll learn about neurons and how it has an axon, and it has coming off of it these things called axon terminals. While your neurons might not necessarily be able to form a long neuron going to a place, you can potentially change the axon terminals. You could potentially change your synapses, which are the connections at the end of those axon terminals. And so, with regards to that, one of the classic ways that we're doing that is through repetition. If we are in these classes and we repeat things repetitively, there is actually a neuroscience biology basis to this. It is something called long term potentiation, where if you're using that connection multiple times, you are actually potentially making that synapse bigger, and you're making it stronger, so that next time you fire it, it really makes the next neuron fire really strongly and helps you be able to answer something really quickly, or it strengthens it. And that's something called long-term potentiation, where the there's something called fire together, wire together. But there's also something where sometimes we'll say, if you don't use it, you lose it. And so it's that idea where if you repeat it, it helps strengthen it. But it's also why sometimes if you don't do something for a really long time, you might have to like repeat that and build up the strength of that skill again. So it is possible to still strengthen connections and change things at the smaller level, but we might not be able to do bigger neuronal changes like we potentially could if we're younger and more plastic.
Right, right. And so, there's that old saying, um, repetition is the mother of retention. And so, I think about with sports, so to speak. They always say, they always tell people work on the basics. work, never forget your fundamentals, because you always fall back to that. And even with, I mean, in the same thing with, I mean, I hate to use the example, but like with the police work, they always have them go to the shooting range, so it's just, I mean, it becomes that impulse to pull, and they can be accurate. Also, I know with even with like martial arts, they have them do, repetitive movements. So it's just like you always fall back to that. Even with, wrestling too, they have just certain things that you do in wrestling that you always practice. They're fundamental things that you know, just go back to. And yeah, it's interesting. And now we're getting some pretty wordy questions here. So, um, so the first question is, which classes will you be teaching? Uh, and I guess do you have an idea of what classes you'll be teaching in the fall? Because right now I'm assuming it's too late to add now for the spring. So what will you be teaching in the fall?
Yeah, so in the fall, I'm going to be teaching tentatively because it's not
Right.
published yet, but tentatively, I'll be teaching Biology 130, which is human biology. So majors and non majors can take that. It's a class where we're going to look at major systems in the human body to learn about how it works in general and how they integrate together. And so, if you want to come and learn more about that, whether you're a major or if you're a non major, come on by. We'll talk about how it normally works. But also, what I like to do is that once you know how it normally works, we can also start to discuss how if something is off balance, how can that lead to something that you might have heard of clinically, like a medical condition.
Okay.
Um, and then, if you're interested in following that further, another class that I'll be teaching in the fall is human physiology, which is biology 260. Um, but do keep in mind that that class has prerequisites to it. One of them, which is human anatomy, which I also do teach, and I might be teaching that in the spring. That is biology 250, where you will learn about structures in the human body from um, tissue types to bones to muscles to the brain, yay, nervous system. And then you could continue on to biology 260 human physiology, where we'll learn about how it functions and go into the mechanisms as to how each one of those systems work, and then we'll integrate it together. And we definitely go more into how it normally functions and how it could potentially lead to pathophysiology too. And so, yeah, those are the classes I teach. So feel free to come on by. I teach those classes. In the fall, it will likely be human biology and human physiology. Um, but if those sound interesting, feel free to take it from me or any of the other wonderful colleagues that we have in the district, in
Take
the
it from Dr.
college.
Lou. She's cool. She's cool. And then, so the next question is, your neuroscience research sounds fascinating. Thank you for the compliment. Excellent compliment. And this is my question is, how many hours per week should undergraduate students expect to dedicate to research work? Is it generally a volunteer work unless sponsored by a fellowship, like in your case?
Fantastic question. And so, with regards to that, my suggestion is talking with the person who you reach out to. And one of the things that I suggest doing is think, what would you like to do? Because one of the things as a student is that there are always things outside of the classes too. And I completely understand that. All of us do, right? We have our classes, but we also have our lives outside of classes. And what I suggest you do is think about all of those things and prioritize them, and and then try to realistically assess how much time can I devote to each one of these, and achieve the level that I want to for each one of those according to your priorities. And so for me, when I was earlier in undergrad, I knew that I wanted to make sure that I had a good foundation understanding of science so that I can get a strong base and I know that I understand the material and that I'm comfortable in my classes. I was really interested in the research, but I did want to make sure that it didn't distract me from building that good foundation. Because the better foundation I have, the better I'll be able to help them later on too. And so I would talk to the professors and I would let them know. In the beginning, I told them if it's okay if I could commit to 2 hours a week and then here and there, maybe commit more hours, just depending on what's needed. And so I think part of it is just trying to set what kind of time do you realistically have, but also come with a willingness to be flexible and adaptable depending on what that professor needs. And the nice thing is that if you have an idea of what you want, and the professor does too, and you're honest and open about it, you might be able to work out a nice schedule that works for both of you. Or sometimes you might be like, thank you for communicating with me about this, but maybe in the future I can get in contact with you again. And so, with regards to the first professor I worked with, she was okay with me coming 2 hours a week to begin with. And then once I kind of got more classes under my belt and I had a good foundation, I was slowly able to work up my hours. Um, it was volunteer work for that professor, but it also depends on who you work for. There are a number of professors who actually do pay um, some, they have paid internships too, and so or they'll have programs. They had some like summer programs where you could come when you didn't have as many classes and you could also get paid. And so part of that is again looking at those lists and be like, oh, this is really great, I'll have more time and I could be paid then too. And so part of it is just going to vary.
Awesome. Awesome. And so we got a next question. It says, so it pertains to gene therapy. And it says, gene therapy has gained more attention for treatment of genetic diseases that causes blindness, like Bardet Biedl. I don't know who that is, but I don't know what that is. I mean, it could be a name for something. And then the question is, do you think children with such genetic diseases also have increased auditory and tactical senses? I mean, you did address that. It says, how do you think gene therapy combined with your research has found will help people with blindness in the future?
Mm. Yeah, excellent question. Part of it is that with time, gene therapy is getting better and better and better. At the point where I was when I did that research, I think the genetic therapy methods at that time wasn't sophisticated enough to introduce the genes yet to the specific neurons that needed those genes. But now, there are more genetic therapies that are being developed that are getting better and better and better. Um, and I think there is research going on right now to see how well they can deliver a gene to specific neurons. Um, but in combination with my research, which was the question, how does it integrate with mine? The way that it integrates with my research is the fact that there's a plasticity window. And so if you did want to introduce a gene, what is that window of plasticity? And do you need to get it in before? Or could you get it in after? And if so, how much after? And even if it's past the window of plasticity, if you're able to help improve vision by 25%, is that something that would be useful? one of the things that's really interesting is that with regards to the auditory system, you might have heard of something called cochlear implants, where when people learned how the auditory system works, you have this thing, it almost looks like a snail shell. It's called the cochlea, but that's where you have auditory neurons. And when neuroscientists learned how it works, in the cochlea, you actually have an auditory neuron that processes a specific frequency, meaning that on one frequency it'll be high pitched, and then on the other end it's low, so low. And what they realized is that depending on why someone might have lost their hearing, if if their auditory neurons are intact and it's actually just an issue further out in the outer ear, you can actually put in a cochlear implant where you put it in the cochlea, where what it does is that it'll stimulate the frequencies
Mm.
that it's detecting. And what I'll do is that researchers found that you don't need to stimulate all the frequencies that people would normally have if they had everything intact. They realized that if you could activate maybe 16 of them, that's sufficient for people to regain hearing. And so usually, and you might have seen YouTube videos about it. It sometimes pops up as a suggestion where someone gets a cochlear implant activated and they'll say like, "Oh, it's really robotic." And that's because they're using it for the first time, and they will eventually learn to interpret those sets of frequencies, and they'll start hearing what's being made. It'll start becoming less robotic as they have repetition, and they can have long term potentiation and learn what it's being associated with.
Okay, that's awesome, man. That's really awesome. Now, oh, cochlear implant. Okay, so you know what? I have seen the cochlear implants on individuals. I have seen those. I never knew what they were, but I mean, I'm assuming it helped with the ability to hear. But okay, so now I know exactly what it is. Now I'm gonna have to go into now you got me going into the YouTube more videos on that. But yes,
Yeah.
I have seen it. It's awesome. And then so we got another just a general comment, this is your energy is wonderful and they're appreciating the presentation. So just ensure that you hear that. Yeah, I appreciate your energy too. It's there, but it's very mellow, which is cool. Cool. It's not like, someone who's, full of energy, car salesman, in your face. So no, it's really cool. It's really cool. So, so you did your research at UC Davis. So what brought you to Kenyatta? You know, what, what was it that made you want to teach, or instruct? Because to be honest, listening to you explain things and then listening to like your reasoning, I mean, it sounds like, you've been doing this for like 30 years as an instructor. I mean, it's just like, how to, just my observation, you know how to speak to the students, um, and you have an understanding of just what it takes to make it. So I'm just like, so, I mean, I'm happy, I'm glad that we have you. So what made you want to get into, teaching?
Yeah, great question. Thank you so much. I So, when I decided that I wanted to learn more about how the brain develops, I decided to pursue a PhD in neuroscience. And I became a graduate student and started working on studying how neurons develop in the brain. And all of that plasticity stuff related to the visual system. And as a graduate student, I really appreciated the fact that Doctors Candace Floyd and Leah Krubitzer were willing to mentor me and teach me how to do research and involve me in the process. And I knew that I wanted to do the same. And so, as a graduate student, I also mentored undergraduate students who were interested in doing research. So, I would allow students to come and help me with my project. And I found that I loved working with them and helping them understand what the material is, but also start to understand how science is a process and how it all starts with a question, curiosity, and a willingness to pursue it. And so that's what I loved. And as I was doing my research, there is that wonderful excitement of discovery and doing research, but I knew that um, my favorite part of it all was being able to work with the students and help them realize it too. And I knew that I wanted to have that interaction and that mentorship of students. And so, because of that, once I got my PhD, I became a postdoctoral researcher to do research and develop my body of work. But I also knew that I wanted to make sure I set my priority that I also wanted to build experiences working with students. And so I again just thought, what do I want? What is my interest? And I went to my boss or the principal investigator, the researcher, and I talked to him. I was very open about it, and I said, "This is what I'm interested in, and I would love to pursue. I will do research. I really like that, but I also want to pursue teaching and working with students." And because of that, um, it was again the willingness to reach out and ask and explore that helped me get in contact with the Office of Education at UC Davis. And I was able to develop a new freshman seminar where I taught undergraduate students how to do neuroscience research and helped integrate them with the neuroscience research community at UC Davis. And I thought, this is absolutely amazing and wonderful. And I really want my priority to be working with students as much as possible. And so, in order to increase that interaction, I started to reach out more. So, I taught with the Department of Kinesiology at California State University, Sacramento. I also um, reached out to Solano Community College. And the reason why I wanted to reach out to community college is that coming from um, a place of diversity myself and going to community colleges and experiencing how wonderfully diverse it is, I knew that community colleges is the most diverse post-secondary educational institution out there, and that I could really just maximize my time working with students there. And so I started to teach at Solano Community College and taught at Diablo Valley College, and then now I am here at Kenyatta College where I can work full time working with students to help teach biology, but also to be able to help the community to be able to come talk at speaker series like this and be part of community activities.
Let me tell you, we are so fortunate to have you at Kenyatta College. I mean, just listening to your experience, your knowledge base, and just the work that you did. I mean, in the spinal cord research, like I said, I personally know. Um, in fact, I personally know two people who suffered spinal cord injuries. One person, like I met, who had, oh no, now I think about it, three. So one person I met who already had his injury. One person I met who was a community college student. I met this person when she was a community college student, and she had her injury riding a horse. And now same thing, C4, C3. And then the third person happens to be my wife's cousin, and he fell off a roof. And so I knew him prior and now post. And it's just like that, spinal cord injuries are more common than people think. And they're so very easy, I mean, to get. You can slip and fall just from a mud puddle. Sports injury, you see it all the time with football, boxing, and it's so easy to suffer in spinal cord to receive a spinal cord injury. And here in San Jose Valley Medical Center, they have the best spinal cord rehabilitation center on the west of the Mississippi. And I've met plenty of people who've come from other states here to start their rehabilitation due to spinal cord injuries. And so it's just like, you're so knowledgeable about the subject matter. You're so passionate about the subject matter, and probably working in the medical field would probably pay you, twice as much than at a community college. So to have you here, it's such a privilege. It's such a privilege. I mean, just listening to how you're explaining things, and I was just like, maybe I should take take a class just to get more, become more educated on just how the body just works. Because to me, biology was not my thing. I loved physics, chemistry I could tolerate. Biology was just like, oh man, it's too much memorization, But just the way you explain it, I'm just like, maybe I should just go ahead and take a class. So we are glad to have you.
And with that, I will actually thank you so much. I do want to go ahead and with that just say that is an absolutely wonderful point that you're making, is that with these classes, when you're taking it, one of the great ways that you can take these classes is to focus on the part that makes you interested in it. Why is it exciting? Why is it interesting in the bigger picture? And so for human biology, anatomy, or physiology, or these science classes in general, it is so applicable. And if you can think about how it applies to you and everyone around you too, it makes it that much more integrated in your life, and it'll help you focus and attend to it more as you're learning it, which in neuroscience has been shown to help learn it better if you're more focused and attending to it because you're interested in it.
Awesome, awesome. So my question for you is, when we return back to campus, um, will you be spending time in the STEM Center for students to have access to you?
I will be. And in fact, when we were still in person, I would go there. So and when I would see like some students there, for example, I saw a student there with bones, I would drop by and be like, hello. And we could hang out and talk about it. So I will definitely be hanging out. You'll definitely see me there.
Awesome, awesome, awesome. Dr. Lou, we'd like to thank you again for spending this evening with us. You're closing out the what's the term that they use for in television terms? I want to say the season, but I'm thinking sports. well, well, you are you're taking the final lap for our speaker series for the semester, and we're glad that you're the anchor. That's the you brought it on home. Yeah, you anchored this episode really well, and it was such a pleasure to have you. And just from the questions and the comments, from the students, it's quite evident that you hit it out the park. And so we look forward to seeing you in the STEM Center, you know, uh, back there somewhere when the semester starts. well, when we're back in person, which looks like it's going to be in the spring of next year.
Hmm.
So it's a while, but hey, we'll get there.
We will. And thank you so much for inviting me. And thank you for everyone who came. I see your names here and I saw your comments too and your questions. And I really appreciate you listening to me and being able to be part of this community. So thank you so much.